All right, hello. My name is Paul. I am a front-end dev, so just the last guy you want teaching you Rust. Please disregard most of the information here, but what I wanted to try to do, calling this building native apps with Rust, and I think it's actually kind of fun. This is actually something that I do and have done and have some success at, as crazy as that sounds. In fact, some of my first Rust code was native GUI code with the Druid framework. But yeah, so what I kind of think of this is kind of a little bit of a follow-up to some of the previous PlebLab workshops. So a couple years ago, I gave a basic like Rust 101. I don't know how outdated this is, but people seem to appreciate it. There was definitely some moments of getting super stuck in here, which is going to happen today, I guarantee you. So that was a fun kind of, and we used BDK to build a simple Rust wallet. So then last week, much more recent, Ben made this Rust wallet with LDK node. So these are on YouTube. And what I wanted to do is, if you think of what is a native app, I'm working on this project called Harbor with Ben, and we used the iced GUI framework, and they're making a native app. And I want to show you this architecture because, well, actually, here, so I'm jumping around. This is what Ben built last week, PlebLab LDK node, and he's showing you how to use the LDK node library. And what you'll notice is that there's this loop. So this is a command line program, and it's looping, waiting for various commands to come through, like exit, that would quit the app, or address, get an address. So this is all running in the command line. But this is the real basic architecture that you want for an app. Especially for something complicated like a Bitcoin wallet, you're going to have this like long running loop of code handling incoming events. In this case, these events are coming from the command line, but nonetheless, they're being handled inside of this app. Now, when you're a humble back-end dev like Ben, things can stay pretty simple, and this is a pretty simple way to build software. And if this is good enough for you, I would say just do this, or just make a web server. Not everything needs to be a native UI app. But if you want to make like a desktop app, GUI, see, actually, I should have Harbor set up to run it. Here's how Ben and I architected when we made this desktop wallet, right? Harbor client is basically the same thing, same style of code that Ben did for LDK node. So that is going to run a loop, and it's going to respond to commands. And then the Harbor UI, that's what I do. And that's my responsibility. They say you ship your org chart. So this project, it has a lot of contributors, but it's been primarily me and Ben recently. And so I'm in charge of the UI, he's in charge of the client, which is kind of like the back end. And so if I show you in here, we have the way they communicate is over this bridge. And let's see, there's a lot of setup. And then we spawn this like message passing thread, and we spawn Harbor core, which is what Ben's building, and I'm just sending messages. Let's see, where is the message passing? All right, I'm sending these UI core messages. So from the UI to the core, I send a message. And it's just basically every possible thing that the front end could do is just encoded as a message. And this is commonly called like the Elm architecture, and ICE really encourages this architecture of ICE is the Rust GUI framework that we used. Let's see if they explain the Elm. So this is kind of the simplified idea of the Elm architecture. So you have the state of your application. And in this case, we're thinking of this application as a front end, this front end application. So there's another kind of almost server that is the back end. So all we really keep in this state is what does the UI need to know to render the interface? And we communicate with, we update that state via messages. And then we use this same architecture to send these messages off to the back end for long-running processes. And so I promise you we will do some coding, but I just want to give you some context of why I'm doing the things the way I do. So a much more popular way to make apps these days is Tari. So ICE renders all the pixels itself. Tari is using like a web view, kind of like Electron, just lighter weight, with a Rust backend. And so this event IPC is basically what we ended up doing in ICE. So you fire an event from the front end, the back end handles it and fires events that the front end handles. This can end up being a lot of boilerplate, which is what we ended up with in our in Harbor. Kind of a nice a foreign function interface like abstraction on top of these messages is in Tari. It's called commands. So we it's still basically all based on these events. But then there's this like invoke handler. I don't really understand. I'm still kind of trying to learn Tari. My goal is, I think in my next app, I'm going to build with Tari. And so I kind of want to learn it. And so I have decided that I'm just going to put you through the process of me learning Tari. And we're going to try to do something, try to get a Bitcoin wallet running with Tari. So, wish me luck. I did try all this morning to get this running and I didn't succeed. So it's going to be a great learning process. Let me close out. This is my test run. Look, I managed to seg fault, which is, it's very, very promising stuff. All right. So, if you have, who here's got laptops? All right, we got a couple laptops. You feel free to follow along if you'd like to. So I have Rust up, and I also have Bun installed. So you can, if you install Bun, that's how we'll initialize this whole desktop app. So let's see, we're in workshops. And we're going to go to Tari and quick start, get started. Don't ever read anything, and we just Bun create Tari app. Let's make this a bit bigger. All right, so we'll call it, I like when I make a wallet, I call it slaps roof of wallet, because you could fit so many Satoshis in it. And so for our front end, we're going to use web technologies because that's just the easiest. There are Rust ways of making, it's like a Rust to web technology kind of shenanigans, but let's just take more of a happy path. I'll use Bun. And I'll use React just because the AI knows it the best. And I'm going to use TypeScript. All right, so that created our project. So we'll cd into there and install. All right, and so then we'll do I'll open this up in Cursor, which is my editor of choice these days, which is basically the AI VS Code that Microsoft wishes it could build. So I'll open up a terminal. Actually, I should show you this. So we have, it's basically a JavaScript project, right? So it's got node modules, and it's got like a static public folder, and this is the source of the website front end of the interface of the app, and then this is the Tari backend. That's the Rust code. So let's get, what was that command again? It's bun run Tori dev. So let's run that in our terminal. So it packages the front end, which goes pretty quickly, and then it's going to compile all the Rust code. Tari is a Rust project, even though it scaffolds it as a JavaScript project. Most of the core logic, and a lot of the reason why there's a lot of safety to Tari apps. They're like well sandboxed. It's because the back end is in Rust. They just used the operating system's native web view. And there we go. So if I say PlebLab, hello PlebLab, you've been greeted from Rust. So that's it. That's how you make a native app in Rust. We're done. So the rest of the time for questions. Let me show you the source of what's going on here. So this is the main function. So this is just starts it off. So the real magic's in lib. So you see there's this Tari command that this is like a macro that Tari is doing some magic to wire up this very simple looking function.
Really quick.
Yeah.
UI template did you go with this time?
I did React and TypeScript. So as you can see, this is actually very similar. If you're familiar with Rust and you've ever written a web server, this is very similar where you kind of make these handlers for requests, and then you kind of register them, the routes that are available. So let's see where in the front end we're calling this. So you can see there's just a function called greet, and it returns a string, and that's the string that we saw here, hello PlebLab, right? Hello, and this is a format string in Rust. You've been greeted from Rust. So if we go into the app, we see that there's this async function, greet, and they helpfully have the documentation, because this is the key thing that you're going to want to be editing. So say like instead of evoke greet with the name, let's do the name plus the name, because it's a JavaScript. You can add strings, right? Oh no, we need name, name plus name. There we go. Just to make the Rust devs mad, we'll add two strings together with with a plus sign, and then we should get PlebLab. So we're going to invoke again, right? So do we have a space this time? Hello, PlebLab, PlebLab. Great. So we've done string addition. But the rest of this, I mean, this is very just standard React code. So all that's really special is this invoke, where it's basically turning that Tari command thing into this async function that's supposedly kind of like a fetch function, basically. That's interesting. These this is set greet. It's interesting that this isn't in a use effect. Maybe I'm not too up to speed on my React idioms lately. Okay, so I want to. We obviously got a running app, but maybe this would be a good time for some questions before we try to make it do some more stuff. Does anybody have any? Any thoughts or concerns?
I have questions after the educated questions.
Questions what?
I have questions after anybody else's educated questions.
I hate uneducated questions are some of the best. So
So to recap, the main steps we did were install Bun and then use Tari.
yes, we installed Bun. Yeah, we're getting a little bit of a recap. We installed Bun, which is kind of like Node or NPM. And then we went to Tari and we installed, we did the Bun Create Tari app.
And then you open it up in the cursor and tell us what it was
Yeah.
in Rust. Thank you. And then for clarification, is Rust the language that we are using in cursor, or are Bun and Tari using Rust already?
So ask for clarification about the language we're using. So what we end up with is a hybrid app that's JavaScript on the front end and Rust on the back end. And the reason you would do this, there's a lot, if you're making like a Bitcoin or Nostr application, there are, obviously a ton of great JavaScript libraries to do that. But typically the absolute best libraries for almost any given thing that you want to make, there's definitely some exceptions, especially in the Bitcoin ecosystem, is there are really great libs in Rust. So like, again, the last week, Ben built a Lightning node with LDK, and it's just world-class quality, Rust, like Lightning library. BDK, same for on-chain Bitcoin wallets. Who's just use this Proton Mail, just built their wallet based on BDK. Square, Cash App people use BDK and LDK, I believe. So if you want something that's like really battle tested, yeah, millions of dollars. And also the design of Rust language is designed for that kind of carefully crafted, like hardened code. It's not as great typically if you want to do something really quickly and experimentally and change things over and over. It can be harder to do that kind of fast experimentation sometimes because you have to be so careful to get it. Rust forces you to be careful in some sense.
Question. So like last week, Ben literally did everything in under an hour. Could you take the code from GitHub and then make a front end using the same
Yeah, I think that would be fun, right?
I was just curious. Is it possible, Paul, to do that?
Yeah, how I would do that is I would basically. I mean, the nice thing, it's all in one file, right?
You don't have to do it right now, but how would the plebs at home do it?
How would the plebs at home do it? Well, so one thing I tried to do before we started this workshop is I went to Gemini and I said, I'm doing a Rust workshop for Bitcoin developers. And I had some ideas of what I wanted to accomplish and asked it to make me a plan. And I said, make it short and succinct. It did not make it short and succinct. It was epic. And there's so much detail to it. And so this might be great, but it's way too much to go through, in an hour of a workshop. But this, especially if you don't really know how you want to build something. And I think Tony's going to hopefully talk about this next week. Maybe Christopher's going to talk about this today as well, of how to use AI, to really effectively plan a project. I'm more of a learn as I go vibe coder. I really struggle to have, a whole app in my head like this, or work from a whole architectural plan. It's hard for me to stay on track, or I have a lot of discoveries along the way. And so what I typically do is I just use Cursor and I just start asking it, for changes. So in this case, what I would do is I'd take Ben's code, right? And the main thing that we really need and this is what I was struggling to accomplish before this workshop, so I'd like to actually accomplish this today. The main thing that we need is we need to get this loop running. We need to be able to, when we start up the Tari app, there's a loop running in the world that we're going to communicate with messages. And so once we have that loop, we're unstoppable, because then we could almost basically copy and paste Ben's code into that loop and fire things off. And this is one thing, this is something I really struggle with, and maybe there's good tutorials that I'm just not finding. But when you typically, let's see, looking for, there's a guide overview. Yeah. Calling REST from the front end. Something that typically happens in these tutorials is they have this idea of calling, they tell you how to call a function, right? And in fact, in the greet function, well, they even called it as like an async function. And so sometimes tutorials, same with ICED, will show you even how to do async functions. But they always have this idea that they return, that they finish in a finite time. Well, where do you put something like, you just received a payment? You know, that wasn't based on a command. That wasn't started by the user. The user didn't fire this thing and just want to sit there forever until somebody randomly paid the money. That's something that you need to have a long-running process running on your computer that can notify the front end of things. And when you break the app up in that way, you actually just end up with a lot of really nice, really nice control and handling errors, handling intermediate states and things like that. So what I would probably do is take this right here, and I've got a reference to lib.rs, right? So this is where all of our logic is going. And it's like, let's see if I can do voice. Hello, can you hear this? Oh yeah, all right, so we can do some voice prompting. I want to make a backend loop, an async function that starts when the Tari app starts, and will store the send and receive handles in the Tari app state. Okay, sounds pretty good. And then I'll paste in this specific line of documentation. And then I did this earlier, in Cursor, you can add docs. So if you add a new doc, you can paste in the doc. So here, I'll do it just to demo it. Let's see, develop. So at docs, and Tari develop. And so it's going to go to that URL and index the nearby docs. So I also, I personally, I think this is worth spending some money, try to get it right. I really like, my buddy Justin had something about, so there's something about when you actually pay per request, you can start making the calculation of whether you're actually getting the value. Because with these other ones, you're spending your own time trying to iterate and get it right. I normally use Claude 3.7 with the thinking checked. But let's go max, because I think you guys are worth it. while this is happening, I'll show you a little bit my cursor setup. The main thing that I've done, I always forget where this is. I have I have this one prompt, 3.7. Claude Sonnet got really aggressive in making tons of changes that I didn't ask for. So this prompt, all I'm really saying is just try to just do one thing. You just make mess that way. All right. So as you can see, it's hot reloading the app in the background, and so I'm going to kill the application for now so that it doesn't need to do that, and we'll just try to get this code right. We could look at so I've seen this before. So there's you have a setup function where you can pass a closure that runs stuff while starting the Tari app. Well, that makes sense, right? So we're going to get a handle to the app, and then we're going to spawn this long-running background task. And this looks like it's matching on messages. The main thing is that, and we created these message channels. Apologies if people are super new to Rust. I mean, this is a lot of Rust concepts all at once. But I want to kind of do this in more of a vibe coding style. Do I have a vague understanding of what it's happening? So let's just click accept all. So it looks like we're missing Tokyo. We probably need to, normally it's pretty good about adding dependency. Looks like you need to add the Tari dependency. Nope. Looks like you need to add the Tokyo dependency. And I don't actually voice code very much, but I feel like it's probably easier to follow in this setting.
So before this, Paul, would you have to go and do this manually?
Mm-hmm.
And if so, how long would it take you to do this
I probably would have done it quicker manually.
Really?
Yeah, so that's the thing is you kind of end up in this mode of prompting. You're a vibe coder, and so it's hard to switch back to I'm a manual coder. And so there's some things that I do faster myself than prompting, but because I'm already prompting, I just keep prompting.
It's kind of like me and writing. When I used to write, it would take me like 2 or 3 days
Mm-hmm.
to write, and then now versus takes me like a night to bang it out instead of like days.
Do you use AI to write?
Yeah.
Mm.
Yeah.
Yeah, so the thing is that you because especially something really precise, like, I mean, I probably also would have done like Tokyo features full here, but they think that this is good enough, so that's fine with me. But yeah, so sometimes the other thing is that when you make changes, sometimes the AI won't see the changes that you made. And so you have to be careful making your own manual edits and then having it do stuff. One thing that right now it's iterating on some code that it seems it got wrong. Seems like it thinks it's figured it out now.
So it's almost like just making sure it has your voice. Like, I guess the equivalent of that would be.
You're just trying to make sure that it didn't do anything retarded. If you become control, that's the thing. I used to be a writer, right? I still write all my own writing, and I think Ben, for instance, is a developer. He doesn't use AI as much as nearly as much as me, and I think if you are deeply expert on something, you're gonna have such strong opinions that the way that the AI does it, it's just gonna annoy you. And so if you want to go really deep on a topic, you're still probably going to be better than an AI at doing it if you want to be a true expert. But if you're trying to go really broad, like here I'm making a UI app in a framework I don't know very well using React and Rust, and I'm going to also import a Rust Bitcoin library I don't know very well. If you're going to try to do really broad, a bunch of stuff all at once, then it's kind of fun.
So it's maybe like the equivalent of like video or audio.
It's like being like a high level manager versus being like the low level in the weeds kind of person. All right, we got Tokyo. All right. We don't have any active errors other than the fact that it's not using this app handle. So I don't know if this is going to do anything. But we have a send to background command, which is pretty fun. So let's see what happens. Actually, there's nothing. I don't think anything will happen, right? Let's see. Because when we need to call this send to background command from the front end to get anything to do anything. Let's see. So we need to get this enum somehow into the front end. Let's see if it even just runs, would be nice. Oh yeah, see it says tells us to use it. You can call the send to background. Oh wow. Ping received. Well, why does it think? Okay. Ship it, yeah. Okay, oh look. Okay, well, I guess I missed these. So it added this these background events that it's listening for. It's got a heartbeat, and then it's also has the sing ping function. So it invokes the send to background. Sweet. Ping sent the background task. All right. That's awesome. So this might seem like, why did I go through all this trouble? But if you'll notice this runtime async spawn move thing, like this now inside of here is a safe space to do long running async things in. Rust really cares a lot about ownership and moving memory around and who's responsible for things. And so especially for async, that can get really hard. So having this spun up is, this is basically the architecture that we ended up with for Harbor. I know other apps are built like this as well, and we have a lot of control. So now that we have our architecture, I would make a new chat, and we'll try to do something. I'll stay on Max for now. Let's see.
Say there was one thing that it didn't do, which is read the events from the back end to the front end. So I don't know if you'll
Oh, okay. Was it this one?
Yeah, the very last sentence, the next step is to enable events from the back end to the front end.
Ooh, okay. Let's do good catch, Don. Thank you. Let's enable events from the background task to the front end. So maybe we could have we could just show when we get that heartbeat on the front end and show that in the UI somehow, maybe update a counter or something. This is not, so you guys know, this is not the best practice to be vague and indecisive when writing your prompt, but let's just give it a shot. And I killed the front end again. One thing that happens with Rust is, because there's Rust Analyzer, right? And Rust Analyzer gives like the lint messages, like, unused import, or that's not a function, or stuff like that. If it's also trying to compile the app, that will end up in contention with Rust Analyzer. And I want the AI to have the best shot of seeing these lints. So I saw this before with the emit, where it can't find the emit, but there is an emit. Let's see. Ooh, what are they doing here? Wow. Complete implementation of a background task with a bidirectional communication. Huge if true. All right. So yeah, this even says periodic data fetching or syncing, long run computations, watching for. See, these are the real, especially for a Bitcoin wallet. These are things I really want that are typically very hard to get in your first like Hello World UI tutorial. And if there's any code you guys want to review, ooh, we got a failure. Let's see. Failed to select a version of Tori. Tori doesn't have a web view feature. Okay, well that's good to know. So were we using any features before that? It was just empty. I think, so this is again where, you know, as much as I'd love to be a vibe coder, I do end up having to figure things out myself sometimes. So there is this Tari emitter trait that it's interesting that this lint isn't showing up for the AI to see that, but I use Tari emitter. Now, so this is a Rust-ism that I've like, this is a valid method on window, but only if the trait is imported. Let's see if that will fix it.
So the Tokyo and the async function is just so we can receive transactions and then it notifies it without.
Yeah. Yeah, so have you ever done any like async Rust stuff before?
Not something I'm learning, but
Yeah, so you know, in like, are you familiar with JavaScript?
I'm just learning Rust right now.
Okay, so yeah, async in Rust typically it needs like an async runtime, and so in yeah, this literally yeah, it's using Tokyo. Tari uses Tokyo runtime. And so you can think of it as like you have things that will happen asynchronously. So they start, but they're not ready to, they're not done right. It's not like adding 1 + 1. It's like got to wait for maybe something that takes a while, like a network request. So you don't want to block the computer on that request. So the Tokyo runtime basically registers like a flag. It's like, hey, I'm going to be here. I'm going to wait for this to be done, and I'll let the computer keep on doing what it does, and then I'll tell the process that called me when this long-running thing happens. So async, you know, this is very common in JavaScript. It's a way of you know, dispatching things without blocking the main thread of computation. So you don't have to sit there and wait for something to be done. But there's a lot of, it adds a lot of complexity because you are doing all this bookkeeping of who am I waiting for, and then how do I, you know, interrupt the current process.
And then what happens once it's received, or like, you know, once the NC syncs.
So what?
I mean, I'm kind of understanding, but like things will happen outside of it, and then it'll inject like, okay, now we do this because we received this transaction.
Yeah, you could almost think of the computer. It's like the computer is just like in a loop doing what it does, and it has a list of things that it's waiting to come back, like a list of long-running processes. This is the world's probably worst async explanation, but it's really important because it's very hard to understand. It's something that makes Rust in particular really hard to work with. But even in JavaScript, I really struggled with some of the async concepts when I was first learning. But you can think of it as it's like got a list of things it's waiting for. And so it keeps on doing its work in a real tight loop. It's going along, and then it sees, oh, one of these is marked done. So that's when it takes the information off. So like, you know, JavaScript's a little easier because it doesn't have this whole Tokyo aspect. So when I await invoke, right? JavaScript will keep doing what it does, which is basically rendering the UI over and over, doing all the logic. If there's like scroll handlers or whatever JavaScripts want to do, or resize events, you don't want that to start to get janky while you're waiting for something to happen. And then as soon as this comes back, it will then finish this calling this function. It's almost like it started calling it because it called it with the arguments, and then it forgets about it until it's done, and that's when it takes the result of that function, sets the greet message, updates the UI. But it's it's definitely one of those ones where it takes like learning it 5 times or to really sink in. But it's good to be. Yeah, and then I didn't even know what Tokyo Select means. We have 22 heartbeats. Why did it stop at 22? Let's see. It's interesting. We got what? Oh, 23. Nice. Okay. Oh, updates every 10 seconds. Wow. Well, that's awesome. So that's the sort of thing, like the exact same logic of how we're getting these heartbeats. See, like, remember what I was talking about before? It's pretty easy to say, like, call a function from the front end. This returns this. That's just one kind of atomic action. That's what most tutorials teach you. But this idea of waiting to be told something from the back end, and the back end being itself, a long-running task. All right, so we are, it's almost 1. We didn't do any Bitcoin stuff. So what I wanted to do is, at first, I guess, any more questions about this current architecture and what we just did? We could do some more like code review. Yes.
And then the other thing was the second one is data. And this is similar to like in a heartbeat. It's like ping is like, yo, are you there? And then if we hear our echo back or some shit, then we can be like, okay, there's something there. We can throw them a ball. Or how do we understand?
Ping shows that if I call a function in the front end, the back end will say something back. Data shows that when I call a function from the front end, I can also include data in my request, which is similar to here. Like it says, like, if I want to say Sam, and heartbeat is this. We're running a loop in the back end. So you notice that like obviously this always stays responsive. We can always, we can keep typing. We're not fighting anything, but like if you've ever written a computer program and you write a loop that goes forever, that should like block your program, right? Well, why isn't that blocking? Because it's running inside of this async runtime. It's basically a different thread. And so while it's running in this other thread, well, how do we ever, hear from it when it finishes one of these 10-second wait times? It gets a hold of the window and emits a heartbeat. And now that I'm reading this code a little bit better, I'm noticing that we're using window emit here instead of like one of these message passing channels. So somehow we're receiving on these, but we're just using the window emit. So to be maybe closer to the Harbor setup, we would use the TX to send stuff from, this is like my back end. So I want to tell the UI about something, oh, that payment failed, or that payment, or a payment just came in. I'm going to tell the UI about it. And then here we match on, let's see. Yeah, we're listening for these different named events. This is kind of more of a JavaScript style of doing things, registering these event listeners. And see, they can have payloads. So the heartbeat has a count. But anyways, this is working pretty well. So what I wanted to try to do is like one little YOLO BDK prompt and see if we can make this into a BDK wallet in like one prompt, and then it'll work or it won't. So let's see. I think I've got this. I guess not. I thought I had the links, right? There it is. Bitcoin Dev Kit. So yeah, BDK. Ben did LDK last week. Lightning Dev Kit. BDK is like for on-chain stuff. It's built not by the exact same team, but generally been mostly been funded by the same organization, at least initially. And so they've broken BDK into a lot of pieces, so you can use just the part that you need. But there's also this high level BDK wallet crate. Well, a lot of people. So, but Steve is, I feel like Steve, not mandatory, is one of the primary people. Yeah, like there's a lot of contributors. A lot of people are depending on this. This has become a really cool part of the rest Bitcoin ecosystem. So what I will do here is I'm going to take this example. So here there is a, I don't want the BDK example. I want the wallet. There we go. BDK wallet. So this is the higher level one. And then we have async, right? We did all that work to get some nice async stuff going. So similar to Ben's project that showed like a one file way to make a LDK node, this is like a one file example of a BDK wallet. So what I'll do is I'm just going to take this. Actually, let's just take the actual. So I can paste this link into Cursor, but I also could just take the actual code and I'm just literally going to put this into the prompt. All right. So we need, in our context, we're going to have app for the UI and the lib.rs. And let's see. Okay. I set up this basic Tari project with an async background, async backend function that can handle messages from the front end and runs in a long running process. I'd like to use this architecture that I built to make a BDK wallet. We'll just use the code from their example of how to make a BDK wallet and try to use it pretty much unmodified. Yeah. All right. Get rid of that. Yeah. And I'll just put this code in here. And then we need, yeah, I'll let it know. You'll need to add the anyhow BDK Explorer and BDK wallet dependencies.
It's not a call Rust project unless there's anyhow.
I actually despise anyhow and try to do my own Rust air enums, but for now, I'll capitulate.
Something I have to live with forever because there's no way in hell I'm changing
Or you have anyhow on your stuff?
No, all your custom.
Oh.
No way I'm changing any of that.
Yeah. Okay. This one thing that this I should have been smart about this. I could have just done cargo add and added these dependencies to get the versions right. So I'll probably have to fix that. Let's see what is the actual version. One point two. Yeah, that's way off. Oh, what would you do, Tony? Would you restart this prompt and tell it that just maybe add the dependencies yourself? Because it's gonna start iterating with bad lengths and stuff.
Yeah, maybe tell it the right versions even. But yeah, definitely stop and revert. Just go to restore channel.
Okay, let's see. What do we need? So let's do cd into the source Tori directory, cargo add anyhow, cargo add BDK Explora, cargo add BDK wallet. All right. And then let's see what features that they used in that example. Need RustQlite. Async HTTPS. BTK wallet. Features. I need a bigger screen. Features.
It's interesting seeing you code and then seeing Ben code. Like, I can't wait to see Tony next week. Like Ben last week, he's just like, this is annoying. Like, he's just one of those. And then Paul's like, oh, wow, it's like, you're more like happy.
Well, thank you.
And then I can't wait to see Tony next week. Tony's going to be like, get out of my way. Like Ninja. He's going to be like Neo, I feel like.
This is driving me insane.
I know, but you have like more of a happy-go-lucky vibe to it. And I feel like Ben's just like more like, oh, no.
Just trying. I'm literally just trying to get a copy of it. Yeah, I appreciate that. I need RustQlite. It's one of those ones where the prompts are not helping me. It has no idea what I want.
This is such a great prologue to my talk. Thank you for struggling.
Christopher's going to show you the right way to do whatever I'm doing right now. Especially.
So wonderful. You get to do all sorts of.
Especially with this ecosystem, it's really persnickety about these versions. So, all right. So let's just take this whole prompt and make a new context. We got lib. All right. And I'm going to say added all the depend. All right. And now we just pray. It's called the prompting and praying process. Yeah, the vibe code life. All right, so it's updating the app message enum. So this makes sense. So this is one thing I really like about this architecture. You just get a very clear, this is the list of things that the front end could possibly ask the back end to do. And then Rust has exhaustive pattern matching, so it knows that you're matching on all of those. It's of course doing the whole BDK wallet implementation. Thankfully, we kind of copy and pasted that. I think it's weird that these BDK examples start with these like hard coded like private keys and stuff. I feel like my normal experience of a wallet is like generating a seed or something, but maybe they don't want to worry about the RNG stuff. We're adding some more stuff to the wallet state, which is the wallet path, which I'm guessing is the DB path. We'll see. We're using their signet. I might swap that to MutinyNet. And I think Ben used MutinyNet in his LDK tutorial. Implementing the wallet operations. I thought the new version of Cursor showed you how much money you're spending with these 5 cent, because it's 5 cents per tool use, I think. Okay, it's adding some front-end UI. That's nice. Any questions while we pray for this prompt?
So after this call, will it show? Will it? I guess how will you know it's complete? Like what will you? Yeah.
It'll stop, and then I'll we'll see if there's any errors where it won't even compile, and if it does compile, we'll see if it behaves, and if it doesn't behave, then we'll read the code. But something like this big, this vibey of a thing, this is not a targeted edit. I'm trying to basically have it do my entire job for me. Something I try to really be clear about, like vibe coding has not replaced coding, because I feel like the need to understand what you're doing, because there's so many things I feel like I couldn't do if I didn't have a good idea of how I wanted them done. And the idea with like the ultimate vibe coding is that you don't even know how you want it done. And that's I think, a very challenging, annoying place to be. I think it's much better to come in with opinions. Even if you gathered those opinions by talking with another AI model just to plan it out. All right. So accept all, and we'll just see if this works. Whoa, what was that? Resources. Additional properties are not allowed. Resources was expected. Did it edit it? Oh, because it's trying to find that wallet path, probably, right?
Well, it probably just made an assumption that should exist, and it might not exist in this code in Atari.
Okay.
It gets confused about Atari.
If you guys aren't on the mic or don't hear what Tony was saying, it might have just thought that's kind of a Atari one thing. Oh no, come on. Like I said, it's very fail. Did it change versions on me? It was like 1.2, right? Yeah. Because it's like you're looking at its own training set rather than live. That would probably be a good MCP tool to add, just something that would list out actual available versions. I wanted to look up something. Let's see. Tari is mad about something. No method named expect. I don't know why it thought it needed that actually. Did this used to be run? Is that it might be another one where it hallucinated the Atari 1.0 stuff? Oh yeah. Oh yeah. Lots of good stuff. Persist backend. RT. Yeah, I mean, this is just we just didn't get lucky. We didn't win with a single prompt. There's some like I don't know mismatched type things. We can try a follow up, but I bet 15 to 30 minutes of messing around with this, we could get this working. But ideally, oh gosh. Where is it getting that ledger? It was just stuck in a loop forever, just switching back and forth between expected and no expected.
There's a new cool tool called OpenCode that'll actually consult your LSP. So instead of like continually pasting the link back to burn your token, it's like, hey, let me check with the LSP to see what the actual thing in the versions that you're using now needs.
That sounds is better than just this, because I know it gets these linter errors, but you're saying it's getting the actual LSP messages. Yeah. It's update the two.
Maybe add the removed.
But remember what I was saying, Car, about how when I edit stuff myself, it doesn't notice that.
Yeah, it's supposed to be fixing compile time errors, not editing fucking configs.
Yeah.
Yeah, it's so frustrating sometimes.
Yeah, this is when I start to get a little salty. Like maybe all caps. When did I ask you to mess with the config? I must have missed that.
You forgot to say retard. I say retard.
I'm worried that it's gonna hurt my social credit score if I type retard too much. I might say it under my breath. Oh yeah, this is 3.7. Just having a good time. Just
I'm sorry, Paul. This is the weekend. I am taking.
Yeah. Well, I clearly have not managed to build a working software at this point, but I have shown you my process. As terrifying as that might be, I don't always just sit over here just arguing with it. At some point, I start to try to figure out what's actually going on and make more targeted edits. I would probably, in this case, decide that this was too big of a task and break that up into stages. Maybe even have like Gemini, come up with a multi-stage plan and then, bring that in here. Or just do that in my own brain. We have fewer errors, but I don't want to cut too much into your time, Christopher. So let's give this one more shot. But we can. Any final questions? Yes. Absolutely not.
Take my money, Claude.
Well, I mean, actually, that's not entirely true. If you want to there's a private key hard-coded, right here. If you just, yeah, memorize that and then derive a pub key from that, and then you can definitely send somebody.
So would that be your recommendation? If you're trying to do something this big and you keep getting errors, use another one and be like, I have this implementation. How do I break it down into steps? Because it kind of goes what you're saying is you should have an idea of how you're going to.
Yeah, ideally, you are the senior dev, right? And this is the dumb junior dev doing the grunt work. And so if the junior dev fails, it's kind of going to be on you to actually solve it, right? You don't really expect the junior dev to be the genius. So you either have to understand it yourself, or you have to maybe work with other AI tools, or start a new prompt. And instead of here's what we're going to build, say here's what I want to build, and start like having a conversation about how you might accomplish it, and then come up with a strategy that could work. Borrow, view. Is this a different? This feels like a different error. Yeah. But yeah, ultimately, yeah, that's why I don't feel like developers are out of work yet. I think there's just more for us to do, and we can get more stuff done, and we can get bigger things done because we have these junior devs working for us. But yeah, I do not feel like my job is being replaced. Now, if I could never figure out this problem, then yes, my job has been replaced, because there's plenty of AIs who can misunderstand the problem just as well as I can misunderstand things. But I believe that, with enough time, enough zooming out or breaking this down into smaller pieces, I'd be able to solve this problem. And I am happy with the architecture that we came up with as kind of a jumping off point. I should have probably committed that so I could revert to that. That'd be another good thing.
I have another question.
Yeah.
Do you recommend ever cleaning your cargo clean, or clearing the cache at all, or you just keep running it?
That's basically just for saving on hard drive space.
So if you make a change, it's okay. You just run it again.
Yeah, that's notice when it was mad about specific versions, like the Rust is very specific about versions of dependencies, and so, oh boy. So yeah, just the fact if you have a bunch of stuff in your cache, it's usually not going to be a problem. I don't know. Send me some money. No, let's see. There's a Signet. This is, I think it's on just normal Signet right now. I am a human. I don't know if we get a balance. Still have 0 sats. Sync wallet. I mean, it could be lying to me, but that's a cool thing that it's doing. So that's like checking all the addresses. But we definitely haven't got any money. Oh, I got money.
Nice.
We're rich. Thank you, everybody. Thank you. Thank you for believing in me. Can I? I can send. That doesn't make any sense. Where did it send it? Is that just like a hard-coded address? And that's not how Bitcoin works at all. The AI knows where to send it. Sending transaction. Oh yeah, it sent it to itself. So I should probably have the same amount of money, minus some fees, maybe. Oh, this is actual Signet, so the blocks take a little while. Yeah, I think the balance just changed. Cool. All right. Well, I'm pretty proud of that. I will upload this code so everybody can see what a vibe code BDK wallet looks like. But yeah, thank you everybody for coming, and yeah, thank you PlebLab.
Thank you.